Hello, dear children. Good morning. I hope everyone is safe and sound in your home, right? And the online classes are going fine, I guess, isn't it? So, you all are aware that we are doing a new unit, isn't it? Light, and the first chapter from the unit light is the refraction of light through plane surfaces, which we have started last week, isn't it? So this week, as you see here on the board, the topic we are going to discuss is refractive index, and I am pretty sure that you have already come across this term refractive index from the law of refraction, isn't it, which is called as also as Snell's law, isn't it? And this Snell's law said that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of media. Now when I say given pair of media, it means that for glass and water, refractive index will be constant. Okay, so this constant is called refractive index, denoted by this letter called mu. Okay, this is how we'll draw here and a u here. So this is what we call mu, MEW, mu. This is the pronunciation, and here this is now called as refractive index. So what is refractive index? So refractive index, okay, of the second medium. See, we always say of the second medium. Okay, refractive index of second medium with respect to first medium is defined as the ratio of the sine of angle of incidence, which is in the first medium, to the sine of angle of refraction, which is in the second medium. So it's the ratio, ratio, let's say, we call it as refractive index. Now why we take that the refractive index is for second medium? So if you see the definition of this refractive index in your book, you will see that refractive index of second medium with respect to first medium भन्छ. Second medium लाई चाहिँ पहिला consider गर्छ. Now why? Because see, if this board here, this page is the medium, so here if I see a ray of light, it travels without any change in direction because there is no change in the medium. But in case the surface S1 is the surface which is separating the two medium 1, and here I have medium 2, and if the ray of light, okay, if the ray of light, okay, is incident on this surface SS1 from medium 1, okay, and it goes to the medium 2, all right, this is the direction of incident ray, isn't it? So here you see that refraction occurs. Why? Because there is change in medium change is happening, and that is why the refraction is taking place. So the refraction is due to the second medium, understand? If there was no change in the medium, the ray of light would have passed or gone through a straight line path without any change in the direction. But here you see that the medium 2 is present, which is actually the cause of refraction of light here, isn't it? So that is why we say that refractive index is for the second medium with respect to first medium, and the sine of angle of incidence, which is in the medium 1, okay, to the sine of angle of refraction, which is in the second medium, the ratio of these two, okay, gives you the refractive index. I hope you all got now, isn't it? So why we are talking the refractive index of second medium? Because presence of second medium causes the refraction. So refraction, see, you need to understand what is refractive index. Refractive index भनेको चाहिँ के हो भन्दाखेरि चाहिँ by how much the ray of light is going to change the path, the direction of path. त्यसले रेले चाहिँ डिरेक्सन, आफ्नो बाटोको डिरेक्सन चाहिँ कति चाहिँ चेन्ज गर्छ, that depends on the second medium. No, second medium denser छ भने, right, like in this case it is the refracted ray is bending towards the normal, means medium 2 is denser, isn't it? Yes. Now if the ray of light is passing or moving away from the normal, means the second medium is rarer. So here you see that the refraction depends on the second medium. So that is why we call this as refractive index. So refractive index, it is a number. Index means a number. Right? Are you getting my point? Refractive index, it is a number which actually tells you by how much, okay, by how much the ray is going to change its direction. Are you getting my point? When it passes from one medium to second medium. So that is why we say that refractive index is of the second medium with respect to first medium. Second medium chara ta ke hundecha, refraction hundecha. Are you getting my point? So katile huncha, that index is called refractive index. So I hope now you all understood what is refractive index. So refractive index tells you, okay, by how much the ray of light is going to change the path, okay, or the direction of the path when it passes from one optical medium to another optical medium. And mathematically, how are you going to find it? By finding the ratio of the sine of angle of incidence to the sine of angle of refraction. Are you getting my point? Now, the other way to know, okay, refractive index, the cos ko of the two medium. Here I have two medium here. All right, okay, I hope you are going, you are getting this. Let me change the color. So here, this is my medium 1, medium 2. Are you getting my point? So here you see that, where is my refracted ray? Refracted ray is here. This is my refracted ray. Now it is in the which medium? Medium 2. So the refractive index. So here sine of I by sine of R will be the refractive index of the second medium. Why? Because the refracted ray is in the second medium. This is another way to know whose refractive index you are talking about. Similarly, if the ray is passing from medium 2 towards the medium 1, so here you see that, okay, you see that this is my refracted ray. Now where is my refracted ray? It is in the medium 1. So now my this refractive index will be of medium 1 with respect to medium 2. See why we are adding this word with respect to, because it is a comparison of two angles. One is angle of incidence, which is in the first medium. Other one is the angle of refraction, which is in the second medium. So comparison of these two angles gives you the refractive index, and that is why it also has no unit. Refractive index is merely a number, just a number with no unit. Why? Because it is a comparison. Ratio it's a comparison of two similar quantities, hence it has no unit. So I hope now you all understood the refractive index here. Okay, so now let me go to the next page. In the next page I will teach you about refractive index, which is called as absolute, okay, refractive index. Now when I say absolute, it is the final. Now how do you find refractive index which is absolute? By comparing the speed of light, because you know that refractive index, okay, or the refraction is actually caused because of the speed of light, which is different in different media. And in the last classes I have told you that the speed of light is maximum, that is highest, that is 10 to 3 into 10 to the power 8 meter per second, and this is the speed of light where in vacuum. Understand? Clear? So with the comparison of speed of light in one medium with another medium, speed of light in another medium, the comparison of these two speeds also gives you refractive index. Did you get me here? Now since the speed of light is highest in the vacuum, okay, or sometimes we also take it as air, because the speed of light in air as well as in vacuum is very much near to each other. Are you getting my point? So now you get one more definition of refractive index, okay, and what is that? It is the ratio of speed of light in vacuum, okay, see, ratio of speed of light, okay, in vacuum or air which is represented by small letter c. So small letter c ले चाहिँ के बुझाउँछ? Speed of light in air. Okay, to the speed of light, okay, in whatever medium that you are taking. The medium may be air, glass, water, okay, or you can say it as in the other medium that is represented by V. This also gives you refractive index. So this is the second formula. The first formula to find refractive index with respect to angles, angle of incidence, to the angle of refraction, sine of angle of refraction incidence, to the sine of angle of refraction also gives you refractive index. Now here we got another relation, that is with respect to speed of light, where in the vacuum. So this refractive index is called absolute refractive index. Are you getting my point? So speed of light, okay, so speed of light, that is c, to the speed of ratio of speed of light in vacuum, that is c, okay, to the speed of light in whatever medium that you are talking about, that is v. This also gives you refractive index. Are you getting my point? And you must remember that refractive index of a transparent medium is always greater than 1. That is, it cannot be less than 1. Are you getting my point? But now here I am talking about the absolute. So when we say absolute refractive index, then we are comparing the speed of light with respect to speed of light in air. Okay, now why is that so? Because speed of light in any medium is always less than the speed of light in vacuum. Vacuum matrai speed of light can be 3 into 10 to the power 8 meter per second, and this is the highest speed of light. Yo banda speed light ko hundai hundaina. So that is why you must remember that the refractive index of any transparent medium with respect to speed, okay, speed of light, okay, in air or vacuum is always greater than 1. Please remember this. Are you getting my point? Yes. So now let us see some example here. Now in the last class I told you that speed of light in where air is 3 into 10 to the power 8 meter per second. Speed of light in water is 2.25 into 10 to the power 8 meter per second. Similarly, speed of light in glass is 2 into 10 to the power 8 meter per second. Now just now we saw that refractive index is the ratio of speed of light in air, that is c, divided by speed of light in any medium. So let me that medium be for the time being be water. So speed of light in water. Now let's put the value. Speed of light in air is 3 into 10 to the power 8 meter per second divided by speed of light in water is how much? 2.25 into 10 to the power 8 meter per second. So these two units gets cancelled. 10 to the power 8 from the numerator and denominator also gets what? Cancelled. So I will be getting 3 divided by 2.25, isn't it? That is 300 by 225 after I remove the decimal, isn't it? Yes, which means 1.33. So you see here refractive index is greater than 1. So whenever you are trying to compare or find the refractive index with respect to the speed of light in vacuum or air, you will always get the refractive index which is greater than 1. Are you getting my point? Okay. Now similarly, okay, let me make some space here. Now in place of water, now let me take glass. Okay, now speed of light in glass. Now speed of light in glass is 2 into 10 to the power 8 meter per second. So numerator and denominator gets cancelled here. So that will leave me 3 by 2. 3 by 2 means 1.5 here. So again you can see here that the refractive index is more than 1. So whenever you are trying to find the absolute refractive index भनेबित्तिकै you are comparing it with the speed of light in vacuum. It is always more than 1, or you can say greater than 1. Are you getting my point? So similarly, you can follow the table that you have in your book on page number 73. If the page number of your book and my book matches, you will see that on page number 73 there is a table which shows you the refractive index of some common substances, and you will see that the refractive index of all the substances given there are more than 1 because they are absolute refractive index. Are you getting my point? Yes. Okay, so now till now we got two formulas to find the refractive index, that is the ratio of sine of angle of incidence which is in the medium 1 to the sine of angle of refraction which is in the second medium. This gives you the refractive index of second medium. Then another relation, thus the one that we used just now, is with respect to the speed of light in vacuum, that is c divided by speed of light in whatever medium that you are taking. This is the second one. Now we can have one more relation. Okay, for example, refractive index of second medium with respect to 1. This is how we write refractive index of, watch it again. How am I writing? Please watch it so that you will understand how to write the refractive index. So I'll write mu. This is the refractive index. Here I'll write 2 in the subscript, and in the superscript I'll write 1. So now this will this denotes I'm talking about refractive index of second medium with respect to first medium. Are you getting my point? Equals to, okay, please watch it carefully, speed of light, okay, in medium 1 to speed of light in medium 2. This is your third formula. So you can use any formulas. Okay, now why we are using this one? Because sometimes you may have a situation like this. This is your glass and this is your water. Light is passing through glass, okay, towards water. Are you getting my point? So now you cannot use the speed of light in vacuum here this is the first medium, that is glass. So you must know the speed of light in glass here, and here now it is passing, the refractive ray is in the water. So here my refractive index of water with respect to glass, okay, this is how I will write, equals to, here I will have a speed of speed of what? Light, isn't it? Where? In glass, divided by speed of light in water. So now this is going to give me 2 into 10 to the power 8. This is the speed of light in glass. And what is the speed of light in water? It is 2.25 into 10 to the power 8 meter per second. This gets cancelled, so I'll have 2 by 2.25, that is 0.089. So this is my refractive index of whom? Of water. Refractive index of water with respect to glass is 0.89. So now you might wonder, it is less than 1, because now here you must remember that we are calculating the refractive index, okay, of two medium, that is glass, okay, and water. Are you getting my point? Here you must realize that the ray of light is passing from glass towards water. So this is not the absolute refractive index. This is the refractive index of water, but it is not with respect to speed of light in vacuum. But this is the speed of light in glass. So that is why the refractive index is less than 1. Are you getting my point? So you must understand this. So here you see that the refractive index, okay, let me change the color here. Okay, here the refractive index, the angle, refracted ray, I'm talking about refracted ray, is in the water. So that is why this is the refractive index of water with respect to whom? With respect to glass. All right, so now today we learned refractive index, I'm not going to do any other topic today because you must understand this refractive index properly. Watch these videos twice, thrice, even 4 times. If you have any confusion, you can text me. Okay, if you have any confusion and you feel that you are feeling a little bit awkward in asking in the group, you text me individually. I will always welcome that. Are you getting my point? So you can ask me personally also if you have any doubts, if you feel that there is some extra, okay, things has to be explained to you, the things that you're not getting, so please let me know. Okay, so we are just sticking to this topic today. Refractive index, it is the ratio of what? Angle of incidence which is in the first medium to the angle of refraction which is in the second medium. Your ratio, let's say we call it refractive index, and this refractive index is denoted by, okay, a Greek letter called mu, and this is how we draw mu. All right, so I hope you understood. Okay, so if you have any doubts, you can ask me in the evening. All right, so that's all for today. Thank you.